All right, guys, let's go ahead and begin. So we're going to go ahead and factor 27x cubed minus 125. So this is a perfect cube binomial because first off, it's raised to the third power, making it cubed, and it's a binomial because it's two terms. Now, the reason it's a perfect cube is because if I take the cube root of each term, it will give me a whole number as a result. So to get started on this, first off, we're going to go ahead and talk a little bit about SOAP. So this is a difference of cubes. And when we talk about SOAP, it's very important that we realize that this difference of cubes is written in the form a cubed minus b cubed. So the first thing I need to do is solve for a and solve for b. Now, when we solve for a and b, we're just going to go ahead and do that by taking the cube root of each term. So when I take the cube root, again, that's taking the cube root, meaning something multiplied by itself 3 times will equal 27x cubed. Now, if I multiply 3x times 3x, that'll give me 9x squared. 9x squared times 3x will give me 27x cubed. Same thing for 125. If I take the cube root of this, that will give me 5, because 5 times 5 is 25. 25 times 5 is 125. Now, if you need a way to do this on the calculator, if you have a TI-84 or TI-83, you're going to hit the math button. The math button is in the top left, about the middle of the calculator on the left. And then when you hit that math button, you're going to go ahead and go down, and you're going to see at number 4, it should show up as 4:3 radical, and then I'll have parentheses there. This will give you the cube root. So if I want to take the cube root of 27, for instance, I'd hit math 4, and then I'd type in 27, and then hit enter. And when I do that, it would give me 3 as a result. All right, and of course, then I realize, hey, we have an x cubed here. Well, x times x times x will give me x cubed, so that's where the x comes from. Now, dealing with this long stretch of factoring, what we want to remember with this is SOAP. SOAP. Same, opposite, always positive. SOAP deals with the signs in front of each term. So since I have a minus that we're starting with, this is a difference of cubes. It's not a sum of cubes. A sum of cubes is a little bit different, and I'll show you that in a second. SOAP just deals with the signs. So I focus in, and we see that we're dealing with a negative, and that's the same with our actual problem. So if I'm dealing with a negative, then my signs are going to go same, opposite, always positive. And that'll always be the case. Same, opposite, always positive. Now again, the a and the b, a squared, ab, and b squared, these will all remain the same. Those aren't changing. The only thing that changes is the signs. Same, opposite, always positive. So if I had a sum of cubes, a cubed plus b cubed, that will equal same, opposite, always positive. So again, it's all based upon what we're given, and then we just follow SOAP. So now that we have a and b, we can go ahead and use SOAP, and we can find out what our actual answer is. So this will turn into 3x minus 5 times 3x squared plus 3x times 5 plus 5 squared. Now, when we do this, very important that when we are looking at this 3x squared, this exponent is affecting both the coefficient and the variable. So I need to square both. I'm going to square the 3, which gives me 9, square the x, which gives me x squared. So our final answer, when we multiply everything out, we're left with 3x minus 5 multiplied by 9x squared plus 15x plus 25. And that is our final answer. All right, so let's go ahead and start working through our review. Again, our review is going to cover everything from Unit 4, so everything about triangles. So let's go ahead and get started. The ratio of the 3 angles of a triangle is 5 to 7 to 8. Find the measure of the longest angle. Now again, feel free to pause the video at any time that you need to. I'm just going to go ahead and start going through this. But if you need me to slow down, if you need to go back through stuff, feel free to pause, rewind, whatever you need to do for this video. So first off, we're dealing with a triangle. So I'm going to go ahead and draw up my triangle. And since we're given a ratio, anytime that we see a ratio, we can give a variable to each part. So the angles of my triangle are 5x, 7x, and 8x. Those are the measures of each angle. So I make a triangle. I called it ABC. And I gave each angle one of those ratios, 5x, 7x, and 8x. Now, I know that in a triangle, the sum of all the angles is 180 degrees, so I can say 5x plus 7x plus 8x equals 180, and then solve for x. When we solve for x, we get x equals 9. Now, from here, we're looking for the longest angle, the largest angle that we have. So if we're looking for the largest angle, well, we look for the largest coefficient, because all we have is coefficients here, right? There's nothing extra added on. There's no 7x plus 4 or anything. So I look for the biggest coefficient. And the largest coefficient that we have is attached to angle C. It's this 8x here. So I plug in x, 9 for x, for angle C, and that'll be our largest angle. So that'll give me angle C is equal to 8 times 9, so angle C is equal to 72 degrees. And that's our final answer. The largest angle that we have is 72. Now, of course, I can plug it into each one and make sure. If I plugged in for angle B, I'd get 63 degrees, and angle A would be 45 degrees. So you can plug it into each, but again, it will be the one with the largest coefficient. So you don't need to spend that extra time going through all that. All right, next step, number 2. Find the measure of angle B. So we have angle A and angle B are both remote interior angles. They're both inside the triangle, and they're away from our exterior angle, which makes them remote. And if we recall, the remote interior angles, if we add those together, their sum will equal our exterior angle. So I have 2x plus 10 plus 4x plus 5 equals 10x minus 45. From here, I can go ahead and start solving for x. I combine like terms. 4x plus 2x will give me 6x. 5 plus 10 will give me 15. That will equal 10x minus 45, and then from there we just start solving for x. Subtracting 6x from both sides gives me 4x. Adding 45 to both sides gives me 60. So 4x equals 60, and then dividing both sides by 4, we get x equals 15. Now that we have x, we're just trying to find the measure of angle B. So I plug in 15 for x and angle B. That'll give me 2 times 15, which is 30, plus 10 will give me 40 degrees. So angle B is equal to 40 degrees total. All right, next up, number 3. Find the measure of angle 1. So we've dealt with this type of problem a couple times. So the first thing that we're going to do is we're going to focus in on our big triangle. Now we see that we have a couple of angle bisectors because we can see that these angles are congruent. So I can go ahead and label each of these. I'll call them X and Y. So I now have X plus Y plus 120 equals the total amount of angle inside of a triangle, which is 180 degrees. From here, I'm going to go ahead and solve for x plus y. So I subtract 120 from both sides, giving me 2x plus 2y equals 60. Lastly, I divide both sides by 2, giving me x plus y equals 30. So that's focusing on the big triangle. I know x plus y equals 30. Now I'm going to go ahead and move to our smaller triangle because I can't do anything else with the large triangle. For the small triangle, the sum of the angles is x plus y plus the measure of angle 1 equals 180 degrees because this is a triangle itself. So using that, I should be able to say x plus y plus angle 1 equals 180, and I can substitute 30 in for x plus y because x plus y is equal to 30, so I'm just going to go ahead and replace this with 30. So I now have 30 plus angle 1 equals 180 degrees, so therefore angle 1 equals 150 degrees. All right, next up, number 4. Find the measure of angle E, and if segment EK is equal to 24, find FJ. So first off, with measure of angle E, we're going to use the mid-segment theorem. The reason I can use this is because I have 2 midpoints, point F and point J. Point F is a midpoint because it's congruent on both sides. Point J is a midpoint because it is also congruent on both sides. So since that's the case, this is a midsegment. Now things about the midsegment, first off, FJ will be parallel to EK, and also FJ will be half of EK. So with that information, if these two lines, FJ and EK, are parallel, that means that HE is a transversal line. So the relationship, because if these lines are parallel, the relationship between these two angles is that they are corresponding angles. One is interior, one is exterior. They have different vertices, and they're on the same side of our transversal. Now, if we have parallel lines and we have corresponding angles, those corresponding angles will be congruent because they are parallel lines. So angle F is congruent to angle E because corresponding angles are congruent. From here, we're going to go ahead and solve for angle F. So for angle F, we know angle F plus J plus H equals 180 degrees because it's a small triangle up top. So with that information, we can go ahead and solve for angle F. We have angle F plus 50 plus 100 equals 180 degrees. Well, 100 plus 150 will give me, 100 plus 50 will give me 150. And I can subtract 150 from both sides, giving me angle F equals 30 degrees. If angle F is 30 degrees, then angle E is also 30 degrees by the transitive property. So we now have angle angle E. We now have angle E. Lastly, we have EK is equal to 24. Now, the longer segment is always going to be double the mid segment, as long as they're parallel to each other. So since these two lines are parallel, this FJ is the mid segment of EK. FJ will be half of EK. If EK is 24, FJ is 12. So again, just keep that in mind. If they gave me that FJ was 15 and they told me to find EK, well, EK would be double of FJ, so EK would be 30. So it just depends on whether you're going from mid-segment to segment or from segment to mid-segment. You're either taking half or you're doubling. All right, next up. Find the coordinates of the midpoints of sides of triangle PQR. So we have our midpoint formula here, and if I find all these midpoints, they'll intersect at a point of concurrency. That point of concurrency is called the centroid. Midpoints intersect at, if we have segments that intersect at the midpoints, those segments are medians, and the point of concurrency where medians intersect is the centroid. So that's what we're finding here. So, to get started, we find the midpoint of PQ. We have our midpoint formula. The sum of our x values divided by 2, the sum of our y values divided by 2. Again, this will be an ordered pair, x, comma, y. So plugging in for PQ, we have 2 plus 8 divided by 2, which is 5. 7 plus 3, which is 10, divided by 2, which is 5. So our midpoint of PQ is 5, 5. Next up for QR. For QR, I have negative 6, negative 5, and 8, 3. 8 plus negative 6 is 2, divided by 2 is 1. 3 plus negative 5 is negative 2, divided by 2 is negative 1. So the midpoint of QR is 1, negative 1. Lastly, for PR. For PR, we have the points negative 6, negative 5, and 2, 7. 2 plus negative 6 is negative 4, divided by 2 is negative 2. 7 plus negative 5 is 2, divided by 2 is 1. So our final midpoint is negative 2, comma 1. We now have each midpoint of the triangle. If we were to create the medians, we would see that each of these medians will intersect at a point of concurrency, which would be the centroid. All right, next up, number 6. Given triangle ABC is isosceles with base AB, and we have each of these angle measures. We're going to solve for x and find the measure of angle ACD, which is our exterior angle. So to get started, there's a couple ways to do it, and I'll show you both. The first way, we have each of our interior angles, so I can add them all together and set them equal to 180, which will allow us to solve for x. So that gives me 3x plus 4x minus 24 plus x plus 12 equals 180. This gives me 8x minus 12 equals 180. Adding 12 to both sides, 8x equals 192, so x is equal to 24. The other way that you can do this for part A is we know that this is isosceles with base AB. So angle A and angle B are base angles. And we know in an isosceles triangle, base angles are congruent. So we can say 3x equals 4x minus 24. From there, we can go ahead and solve for x as well. This is just another way to solve for x. And we would have gotten negative x equals negative 24. From here, we divide both sides by negative 1, which will give us x equals 24. So as we can see, regardless of which way we solve for x, we would have gotten x equals 24 as a result regardless. Now from here, there's a couple different ways that you can solve for this now. You can plug 24 in for angle A and B and add them together. That'll give you your exterior angle. Or what I'm going to do is I'm going to plug 24 in for angle ACB and then I'll subtract it from 180 degrees. So if I plug 24 in for angle ACB, I get angle ACB is equal to 24 plus 12, which is 36 degrees. I see that we have a straight line here, which means that this is a straight angle, something we can assume from a diagram. So I know that the total angle amount right here is 180. So for angle ACD, I'm going to take 180 degrees, and I'm going to subtract the 36 from it. That will leave me with angle ACD. So therefore, angle ACD, should be a D here, is equal to 144 degrees. All right, next up. What is the slope of the median from point A to BC in triangle ABC? So, first off, we need to go ahead and find the median of, we need to find the midpoint of BC because we're finding a median. And I know that the median goes from a vertex to the midpoint on the opposite side. So first off, we find the midpoint of BC. So that'll give me 6 plus 10 divided by 2, which is 8. 17 plus 5 is 22, divided by 2, which is 11. So the midpoint of BC is 8, 11. From here, I now have 2 points, so I can find the slope between 2 points. So I'm going to use my slope formula, y2 minus y1 over x2 minus x1. That will give me 11 minus negative 1 is 12. 8 minus 7 is 1. 12 over 1 is 12. So our slope is 12. Again, this is just a median of this triangle. All right, next up. Determine if the statement is always, sometimes, or never true. The median to the base of an isosceles triangle is also the altitude to the base. So for these types of questions, draw out a picture. It's very easy to draw out a picture here. If I were to draw out a picture, I would see that this is always going to be true. The reason for this, if I draw a median, let me go ahead and draw a second picture and I'll work my way through it. If I have an isosceles triangle here, I already know that the legs are congruent. I also know that this is a median, so therefore it's going to intersect at the midpoint, which means that the bottom two segments are going to be congruent to each other. Lastly, that middle segment is congruent by the reflexive property, so these two triangles are congruent by side, side, side. If that's the case, then these two angles are congruent by CP, CTC, and since these two angles are congruent and supplementary, that means that they are right angles. Since this segment also goes from the vertex and intersects the opposite side at 90 degrees, it is also an altitude. So it's not only an altitude, but also a median. That is always going to be the case for isosceles triangles and equilateral triangles. It will never be the case for scalene triangles. So just keep that in mind. All right, next up, number 9. Provide the given and prove. So you're just going to write out what's given and what you're trying to prove here, nothing else. It goes with the conditional statements that's given to us. So if something occurs, then something occurs. Anything after if is going to be for our given. Anything after the comma or after then is for what we're trying to prove. So it says, if a segment is the median to the base of an isosceles triangle, it bisects the angle of the triangle. So first off, we have a median here, AD. We have a triangle. They're telling us that this is an isosceles triangle. So I can say that ABC is isosceles. And I also know that we have a median. So this median is saying that BD is congruent to DC. So that's what we have so far. AD bisects BC. That's based upon the median, once again. And triangle ABC is isosceles. If you said BD is congruent to DC, if you said AD is a median, all those things are perfectly okay as well. But just make sure that you have something that you can use from your given. For what we're trying to prove it bisects the vertex angle of the triangle. Well, our vertex angle is angle BAC. So that would mean that angle BAD would be congruent to angle CAD. So that's what we're trying to prove. Angle BAD is congruent to angle CAD. Again, realize that this is a conditional statement. Anything after if is given. Anything after the comma or after then is what we're trying to prove. All right, next up, number 10. If If angle B is equal to 4x minus 10, angle A is equal to x plus 30, and angle BCD is equal to 2x plus 50. Find the measure of angle ACB. So first off, we already have it all drawn up here. We have two remote interior angles, and we have our exterior angle. We know that if we add our two remote interior angles, it will equal the exterior angle. So we go ahead and we do just that. This gives us x plus 30 plus 4x minus 10 equals 2x plus 50. Combining like terms, we have 5x plus 20 equals 2x plus 50. From here, we subtract 2x from both sides and subtract 20 from both sides, giving us 3x equals 30. And solving for x, we get x equals 10. We're trying to find the measure of angle ACB. So that's our interior angle here. So I'm going to go ahead and plug it in for our exterior angle, and then I can subtract it from 180, and I'll have my interior angle. I can also plug 10 in for these other two angles, and then combine them all together and set it equal to 180, solve from that. But we don't need to. It's totally dependent on how you want to solve it. So lots of different ways to go from here. I'm going to go ahead and plug into our exterior angle. That'll give me 70 degrees for angle BCD. 2 times 10, which is 20, plus 50 is 70. And I know that we have a straight angle here because we see a straight line. So I can do 180 minus 70 will give me this interior angle. So therefore, angle ACB is equal to 110 degrees. All right, next up, number 11. What is the name of the point of concurrency of the medians of a triangle? So if we're dealing with medians, it's going to be a centroid. Medians intersect at the centroid of a triangle. Meanwhile, angle bisectors will intersect at the incenter. So medians at centroid, angle bisectors at incenter. Make sure that you guys are familiar with these terms and angle bisectors, medians, altitudes, all that type of stuff. You'll need to know all of it. Next, find the point of the intersection of the medians of the isosceles triangle shown. So, medians. Medians intersect at the centroid. So we're finding the centroid here. Now, the centroid is right here. Now, if I look at this top point, 6,4, and this bottom point, 6,1, that gives me a lot of information about the length of this median. The x values line up, so I can just count up the y values. And I can see that this is length 3. Now, from what we learned about medians, we know that in centroids, the longer part of the median is twice the shorter part. So if the long part is 2x, the shorter part is x. So I can go ahead and set up that ratio over here as well. I could say, oh, this is 2x, this is x. The next thing that we need to do is we need to find the total length of this segment. Well, if I look at it, I'm going from 1 to 4. So the total length is going to be 3. Go ahead and get rid of my x's here for now. So the total length is 3, and again we have 2x and x. Now, at that point, I can go ahead and set up my ratio and set it equal to the length. So I have my ratios is equal to length, or distance. So my ratios, I have 2x plus x, that's my total ratio over here, 2x and x, and then that's going to be equal to the total length of this. So that'll be equal to the total length, which is 3. From here, we just solve for x. 3x equals 3, and then dividing both sides by 3, we get x equals 1. Which means that this length is 1, and this length is 2, if I plug 1 back in. So if I were to plug 1 back in for each of these, we get length 1 and length 2. So therefore, the centroid is just up 1 from this midpoint down here. Well, if the midpoint is 6, 1, that means our centroid is going to be at 6, 2. Let me go ahead and get rid of all my markings so that we can see it easily. The centroid is at the point 6, 2. All right, next up, number 13. The vertex angle of an isosceles triangle is 100 degrees. Find the measure of one of the exterior angles at the base. So first thing I'm going to do is label the vertex angle as 100. It's isosceles, so I can mark base angles as congruent as well. So I have 100, and then I have x and x. I'm also going to extend it out so that we can see this exterior angle here. And I can set up the sum of my angles as x plus 100 equals 180 degrees. Combining like terms, that gives me 100 plus 2x equals 180. Subtracting 100 from both sides, we get 2x equals 80. And then dividing both sides by 2, we get x equals 40. From here, to find the exterior angle, I know that these are supplementary angles. They form a straight line. So I can do 180 minus 40, and that will give us this exterior angle. So 180 minus 40 will give me 140 degrees. That is the measure of our exterior angle, angle BCD. Next up, number 14. What is the slope of the perpendicular bisector of AB? So if I need to find the perpendicular bisector, specifically the slope, all I need to do is find the slope of AB, and then I can do the opposite reciprocal to get the perpendicular slope. So first off, to find the slope of AB, we go ahead and use our slope formula, y2 minus y1 over x2 minus x1. That'll give me negative 1 minus 5, which is negative 6, 7 minus 6, which is 1. Negative 6 over 1 is just negative 6. If I'm finding the perpendicular slope, take the opposite reciprocal of our slope that we just found of negative 6, and that'll give us the slope of 1 over 6. Again, opposite reciprocal means flip the sign for opposite. Reciprocal means flip the fraction upside down. And our final question for the day. Factor completely and then check your answer by multiplying it out. We have 8x cubed minus 27. First thing that we want to do here is we see that's a difference of cubes, so we'll write out our formula. So we have a minus b, and we don't want to forget our SOAP. So we have same, opposite, always positive. From here, we're going to go ahead and cube both of these. Take the cube root of both. Cube root of 8x cubed is 2x. Cube root of 27 is 3. Plugging it into our slope form, we now have 2x minus 3 times 4x squared plus 6x plus 9. That is our final answer here. If we were to distribute through the parentheses for both of these terms, it would cancel a lot of stuff out and get us right back to 8x cubed minus 27. All right, so that is it for today's notes. That is it for our review. If you have any questions at all, please contact me. Let me know what's going on. That way I can help you out. Other than that, thank you so much for watching, and have a great rest of your day. Take care.